Alright, let's go. Oh no, my lambda is not open. Okay. And now we go. So we got name, icon, also low and high. Create a table out of this. We'll just call it T. Over here, we just want L's and H's. So we call this tide and time. I'm not sure on this 2 a.m. I might want to create another 2 a.m. but with the next day in there, just in case. So we'll call this TT. Okay, so here we want the probability during high tide for each of these animals. So T high. And then we're just going to multiply those probabilities together, multiply by 10,000, and we're good. Okay. So we want to know when the next tide phase is. So we're going to do a look forward, look up, TT time, TT time. Using the look forward feature, and just in case it starts on a number that matches the table, I'm going to add a small value so that we're guaranteed to get the next time. And it won't give me the exact time again. So we're going to call this next tide and save this as a lambda. Alright, so we got our lambda. Now, we want to say that minus that times 60 times 24. I'll put it in number format. And then I need to round to 0 just to avoid floating point errors there. Okay. Now, given the following times, find the probability. Okay, so this is like a weighted average. I'm going to find the next tide, which is next tide of that. I also want to find the previous tide. So it's always going to be the next tide, TT time, minus 1. I can look that up in TT time. So there's our previous tide. I like that one. Let's name that lambda. This should be a game show. Name that lambda. Okay, so now we want to know the percentage of the distance that it's crossed between the previous tide and the next tide. So we'll say time minus previous divided by the next minus previous. It should be represented, there we go, by a decimal. And then we'll look up, first I need to know, is this low or high that we're starting at. So I'll say let's look up the previous tide and give me an L or an H. So then I think this whole question is just dealing with crabs only. So equals the crab icon. And oops. This is going to be icon because we're going to use this in the future for our lambda. Now, once we know that it's low, we can say xlookup the animal icon, and then we want to say if that equals low, then return t low, otherwise t high. And then we're going to do the same thing, just swapping this L and H, because the next tide comes, it's the opposite column. Okay, so to get a weighted average, we're going to take the percentage and apply it to the percentage of the next tide, which is 0.3, and then we're going to add 1 minus our percentage times the previous tide percent. So that's our weighted percent, and that is what we will get a name lambda for. Say lambda. Okay, now just take that, round that times 10,000 to 0. Okay. Level 4. Since we have that lambda, now we can just apply it to all three using a reduce. So reduce from 1, giving these animals as inputs, and the AB percent. Our time is this, and our animal is this. And that came back wrong, actually. Let me think. I have the wrong logic here, or is my lambda up top wrong? I wouldn't expect the lambda to be wrong because it gave correct answers here. So what am I doing wrong? The time is given correctly. The icon is there. Oh, I know. I need to carry forward the amounts. Okay, so times 100 times 10,000 rather, round 0. Okay. Let's see these last two, and we need to filter out the blanks. So 2 row. There we go. Okay. So now we have to do the same thing, only we also have to consider that we actively don't want to find the ones where we're not supposed to. So this formula here takes care of, let's not do the rounding yet. That gives you the percentage of just the 3 positives, the 3 that we want. And then we also need to get like the same thing for the negatives. So instead of this input array, we'll say filter this where this is empty. Okay. Now we fit this. Yeah, I'm gonna need to do a 1 minus here. So now when we multiply these together, yes. So this would be our combined percentage to find a whole array of animals. Let's mark these as inputs. Combined percentage, save lambda. What did I do wrong? Something went wrong here. It's supposed to be equals this times this. Save lambda. Okay, I think we're good now. And then equals round that times 10,000 to 0. we're taking that logic and we have to find what time gives us the highest amount. So we'll map a sequence, and that sequence should go from 12 a.m. to the first high tide, low tide. So it should be 60 times 6 plus 30. Let's start at 0, and then lambda v. Okay, lambda v is our times. So for each time, we're going to say combined percent. I'm going to say equals over here. Combined percent of our time, which is, we need to divide by 24 by 60. Okay, so v and our inputs for animals are here. So that gives us all these values. Let that be t, and then we'll say x match max t minus 1 because we started at 0. Nice. Alright, this time we're picking up one creature. We want to know how many rocks, so we have to turn over to get 99% chance of finding one. A little bit of probability here. So it's going to be, I don't know how many it's going to take, so we'll map a sequence of say like 100. Map 100. 1 per minute. Yeah. Okay, so lambda v, the percentages are going to be PCT v divided by 24 divided by 60 for this guy. So those are my percentages. Let's do 1 minus. We want to find where probably not. Okay, so now we'll scan that. Starting at 1, product. And then we're just going to look for X match, first value that's under 0.01, less than or equal to 0.01. Wrong answer. Why? Percent. We're not rounding anything. Let's take a step back. That's the value of our scans, and we're wrong right at the beginning. Should be. Oh, we're not. I started at 12 a.m. We need to start at this time. So let's undo this and then just change our start time to be sequence 100, but starting at this time. So it's going to be round this time times 60 times 24 and round to 0. Still wrong answer. How can that be? Well, let's check our scan again. Our answer didn't change by doing this. That is odd. Isn't that odd? That our answer didn't change by changing the start? We're pointing at this time, changing it to, oh, why did I do divided by? There we go. Okay, so let's bring it back, change this to multiply. Aha. Okay, good. Bonus questions. At high tide, what is the probability of finding no marine life? Okay. So round, I guess it's product of 1 minus this. Times 100. There we go. What marine life species are you least likely to find under a rock at 3:30 a.m.? Okay, so then we'll say rank by, and I want to find the likelihoods. So I'm going to map T icon, lambda v, and then we'll just find the percents at that time. So 3:30 a.m. is 3 times 60 plus 30 minutes. That's an integer time. I also need to divide by 24 divided by 60. Then your animal. Okay, and then what do we want to rank by? We're going to return the names here. So T name, least likely is 1. Okay, -1. One of the marine life symbols occurs more frequently than others. How many times? Okay, so just go to our case rows. I have a macro that put these together for me. So we'll just filter on all the animal icons and then just say most of and 1. Return the count. 45. Right. You check under a new rock every 1 minute. How many frogs would you expect to see? Okay. Round, sum. So we're going to map a sequence of 6 hours and 30 minutes. Starting at 1 is okay. Number E. The probability of finding a frog is E divided by 24 divided by 60. Finding the frog icon here, and then round to 0. How many minutes after high tide? Do the same sequence again. Probability of finding. So we're going to reduce after each one. So we'll say equals map sequence 60 times 6 plus 30, and T for time. At each time, then I want to reduce from 1 using all the animals. Lambda AB. We want to find all of them, right? So that's going to be A times percent T V. Okay, so that's all of the probabilities, so let that be X. Then we want to do X match, max X on X, and we got an NA. Didn't like something. So let's bring it over here for debugging. X. Okay, it's only finding the first value. Only finding the first value. Y. Map the sequence. What am I doing wrong here? We're mapping all these values. And those look right. Lambda T. Oh, they're integers. Divided by 24, divided by 16. I keep doing that one. Okay, 12:50. 19 minutes. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.